All right, so here we are. This is 128, hacking mobile devices. And you look at the schedule. Here, we're in the second class here. Now, they are not doing the chapters in the book at in order, because iPhones are going to be hard for us to do, and many students will not have the right hardware and not be able to do it. So we're primarily going to focus on Android. So we do the first chapter, which is general overview of app security, and then we're going to skip to the second half of the book so we can start with Android. And we'll go through Android, and we'll do iOS later, and I'll talk about getting people iPhones to use as much as possible at that time. Anyway, so that's the plan. And then I'll demonstrate some of these things during the lecture because you'll see some of the tricks that you're going to have to get working on your machines to do these projects. And as I warned you before, these projects are pretty difficult. It depends on your hardware and your operating system. So it may take quite a bit of work to get these emulators working correctly, but it's very nice when you get them working. So let me clear this. All right, so I'm going to share my slides, which is here. This one. Nope, not that one. There it is. All right. There, that should be the right one. Chapter 1. Okay, we're on the road here. So the first thing, of course, is the prevalence of various shares of phones. And Android is number 1, has been for many years. iOS is number 2. And everything else is dwindled away to nothing. Things like BlackBerry, Windows phones, and everything are all gone. That's pretty much all there is. They're both Linux. This is why, remember, years ago, Windows had 98% of the desktop market, and people waited for the year of Linux to win over desktop. And Linux never won the desktop, but it won everything else. The phones and the tablets are all Linux and Unix. The home devices, your security cameras and everything are. The only thing it didn't get was the desktop, where a lot of those are still Windows. And servers, quite a lot of them are Windows. Anyway, so you can talk about the attack surface of any kind of software or hardware, and this is the various ways that you might get attacked. I'm just sort of wondering if my camera is broadcasting anywhere. I don't see it, which is a little strange. Anyway, we'll just carry on. So, it isn't. That's why I don't see it. Okay, there we are. Good. All right. Have a little trouble with my Zoom today, but we'll carry on. So you have the network communications. Traffic can come in over the Wi-Fi, to a much lesser extent over the cell phone network, because that's not a shared environment. They can just steal your device and get the data on it if your device is not encrypted. One thing that's really common is malware on your phone. It's not common in iOS, but it's very common in Android. There's a ton of malicious apps in the Google Play Store, and a lot of people load apps from other sources. And then there's a lot of other ways data enters the phone, and any of them in principle could be used to attack it, but those aren't as common. So here's some example of defects seen in applications, leaking sensitive data where it shouldn't go, having hard-coded passwords, lack of binary protection in almost every app, which is what we're going to exploit quite a bit. You can see the source code. You can just examine apps and manipulate them. And sending data insecurely over the internet or storing it insecurely locally are also extremely common. And we're going to see all these things. So in general, this is the number 1 problem in all of the world of security, is developers just don't understand security. They're trying to make apps run fast and make them pretty and develop new features, and they really don't understand the security consequences of their decisions. And also, they just include libraries that come from elsewhere, and those often have known vulnerabilities. So there's an OWASP mobile top 10 risks, and this is an older version of it that I thought was quite good. The number 1 vulnerability on your phone is not on the phone, it's on the server. The requests made to the server to retrieve data are often poorly designed and leak out data. But then there's a lot of things here like insecurely storing the data locally, insecurely encrypting it as you send it, and there's lack of binary protections, considered a less serious vulnerability, but extremely common. So OWASP, they're all here. So that's the most critical issue. on the phone is actually on the server, and we have a whole class just in this 129S securing web applications, which is largely about what goes wrong on the server side. So some people store data locally that is either not encrypted at all or encrypted with very weak routines that don't really protect it, which is called obfuscation, when you make it a little difficult to read something, but you don't really encrypt it. And the most common failure of transport layer protection is using HTTPS, but not verifying the authenticity of the certificates. So it will accept fake certificates. That is surprisingly common. And then unintended data leakage is where you put important data somewhere foolish, like in the cache or snapshots, where it's not secure. Poor authorization and authentication means you don't keep track of who people are very well, so you don't limit what they're allowed to do. Broken cryptography is often a hard-coded key. And client-side injection is where an app can receive a request from another app that leaks into your app. And security decisions by untrusted inputs. This is where some information that determines whether you're allowed to do a secured activity comes from something that's not really trustworthy. And improper session handling is common, where you can steal a cookie. This is true in web apps too, and then you can get in somebody else's session. And we talked about lack of binary protections, which lets you essentially see the source code or something close to it and modify apps. So there are a lot of tools that can be used for this. There's a framework to develop secure iOS apps called iMass. I've never tried it. There are some deliberately insecure apps to practice on. I used some of these the first time I taught this course years ago, and it was very unpleasant for the students and me. These things were old and nasty, and I quickly just started using real apps, which is what we're going to use here. And there's a mobile pen testing distribution and an Android forensic distribution, a lot of tools, which we haven't used. And then, when I did this, that led to this class, I checked the top banks, insurance companies, and stockbrokers and found a ton of vulnerabilities. And then I found a bunch of medical apps that were breaking HTTPS. And, the banks are all vulnerable. We'll be hacking into some of these apps. And the stock traders are vulnerable. And the insurance companies are vulnerable. It is ridiculous. And most of them don't care. The ones that break HTTPS will fix it when I report it to them, although sometimes it takes them up to 2 years to fix it. But none of them care at all about binary protections yet. And here's another bunch I disclosed at DEF CON from retailers and stuff. I just started going through the top 100 retailers and found more of the same standard vulnerabilities. Anyway, so I got some cahoots about this stuff. Let me share that, which is cahoots. That should do it. And this is 128, chapter 1. All right. Good. It's following the tabs correctly, although I'm opening the wrong one, so that's not right. All right. What is this nonsense? Chapter 1, play. Here we go. All right. Okay. Oh, it's not showing the right page. Thank you for telling me. This sharing thing is very buggy. And it's now still showing the wrong screen. Wait. It's failing to update. My goodness. All right. I'm going to try stopping it. See what happens now. It's again failing to update. My goodness, this Zoom thing is being quite buggy today. See if it will let me share something else. And it will not. All right. How about this?
Hey Sam, the code. Some folks were asking, how do we?
Yeah, I could. They can't play the game though if they can't see the screen. That's the thing. I'm going to pause the recording. All right. Well, let's see if it works now. If I open this page, Not that page, but this page. That looks right. And that. There, now it opens. Okay, so we may have occasional interruptions, but I guess we can carry on. This is not good that Zoom is so buggy. I'll try updating it after class. Maybe that'll help. All right, good. Oh, there's somebody vaccinated in the class, or else you're joking. That would be nice. I wish I was vaccinated. It looks to me like the screen is again not updating. Because I can see my screen. It only has Golden Lemmings 35 and 9 students, right? That's what I see. Is that what you people see? Yep, frozen again. Yep. Well, I'm going to try.
Yes, the screen is freezed.
I'm going to try stopping the share and sharing again. But I don't know if we're going to be able to do anything good this way. I start screen sharing. Oh, I have an idea. Let me get rid of this. And now try it. No, it didn't help. Well, it won't kick in. Well, there is another thing I can do. Let me try that. I'm going to kill off some of my screens. Maybe that will make it less confused. I've lost my mouse. Well, that goes up here. Here. All right. Well, all right. Now I have a mouse again. Let me see if I can share anything. All right. I think I'm going to have to shut down the Zoom session entirely. And I'll update my Zoom and try to go back to like maybe just one screen and restart class. So I'm going to shut everything down. I'll come back in about 5 minutes.
Okay, thank you.
Yep. If I can figure out where it is, it's vanished on me again. Over here is something. All right, there it is. Okay, but I can't get there. Aha, I'm somewhere. All right, I got to fix this now. My goodness. The display I need to get to is not reachable. There. There we go. Oh, okay, good. So I can end this.